from Barcelona. Randa, over to you.
Someone, yeah. That's person one.
Yes.
Yeah, right.
No, it's
We'll just do it without notes. Right? It's okay. We'll manage.
Thank you.
Yes, thank you. So, forget about that. Thank you, Flaminio. Federico. And for inviting us here. It's been a blast so far, so it's really nice. And yes, I wanted to talk about personal networks at ABM. So we have been talking about this integrating social networks and ABMs. And then, of course, we're thinking a lot about social-centric networks, right? Because that's the most, sort of the most evident thing to do, is to look at social-centric networks. But I come from the sort of peculiar tradition of personal networks. And I think that we can also use personal network data for ABMs. And so I wanted to talk a little bit about that. So first, let me make the point that we made in our book with Raffaele and Chris McCarthy and Jose Luis Molina. I think this is the graph that is actually my reproduction of what Raffaele made for the book, much nicer graph. But anyway, the idea is that actually social-centric networks and personal networks are different ways of sampling from the whole network of the world, so to speak. So if we're doing social-centric networks, we're looking at that direction, right? So we have one particular setting, a bounded setting, like a school or a village in the mountains or someplace. And then we look at all the relationships between the people that are living there, for example, in that particular context. And personal networks, we actually look at the person and we follow them through the different sort of settings. So it's another way of looking at network data, right? So we are interested in the people that surround a specific person, and it doesn't matter in which context they actually meet each other. So, but in fact, they are very much related. And so when you use one type or another, it also depends on the questions that you have. So if you're, for example, interested in burnout at work, then it makes sense to look at the work context, right? I mean, even if people will have also social support from outside, for example, the problem probably is created at work, right? So it makes sense to look at that, for example. But there are other questions for which it actually doesn't make so much sense to look at this particular, to look at a particular setting, that there are individual outcomes that are actually influenced by or social relationships independently of where we meet. Right? So, for example, also Raffaele, we're both looking at embedding of immigrants in a new society, and where that isn't something that just happens at work or just in the neighborhood, or just in one setting. And how to figure out all the relationships that people have. Another topic is, for example, this opposite process of gradual exclusion from social life of people who experience chronic poverty, right? So once they fall into poverty, they're being gradually excluded and also withdrawing from social life. So this is also a process that doesn't happen in one setting, but is more, pervasive. Intimate partner violence is another of these topics, right? We actually think about one diet, right? The victim and the abusive partner. But of course, it's also embedded relationally in a larger setting of relationships, that they can also happen in the family or at work or wherever. And so many of these topics, we look at that with personal network analysis, and then we get to these micro level behaviors of what people do and how people create relationships and how we, what is going on there, right? And in fact, that's also very much related. These are micro level behaviors, but it's very much related to these macro level processes, for example, of cohesion and segregation, of in and exclusion at a more macro level, at the societal level, right? Or polarization, for example. So we try to collect these data on the personal network level, but we actually try to say something about wider processes that are going on in society. And so this already shows this micro-macro link, already shows that it might be interesting also to look at that from a different perspective. So then why the limited use of personal network data in ABMs? Well, it's probably kind of obvious for you, but each personal network, so this is one of these personal networks with just 45 relationships for one person. The person is not in the network because they are related to everyone else. So it doesn't make much sense to project them there. But these are 45 of the relationship of one particular person. And of course, it's a network, but at the same time, this network only makes sense to one person, right? So all the other people have relationships outside of this network that are more important to them. So it's actually the ego for which this particular network is of interest. And the second thing is that therefore, because of that, we tend to simply aggregate these kind of things, right? So we use regression models or multi-level models in which each person is sampled and they are one case in the analysis. And then, yeah, what we find is simply sort of aggregated, simple, sort of taken an average of all these cases to say something about these social processes, right? But it's a very simple aggregation. There's no relationships among these egos, for example, that then can say something more than that. So if we want to create a world where everyone has a realistic personal network, right, we should actually create a social-centric network, and that's an extra step. And that's the problem, then therefore, probably. However, I do believe, strongly, we believe, actually, as a group, that it would make sense to also integrate personal network analysis. First of all, for incorporating personal network data and ABMs would create more realistic networks of social worlds, right? We've been talking about that, and I really like the presentation again also to see different ways of how to do that. And yeah, we actually try to take these personal network data and then use them to sort of feed them into a network. Miha will talk later about that as well, to create a sort of a social realistic network that for some type of applications might be of interest, of course. Not for everything, but you could use them as ABM environments for models that we're already using, right? On top of that, it might make sense to use ABM to model processes that are typical in personal network analysis, but not so much in ABMs, right? So for example, social capital is something that is a really big topic in personal network analysis. And so, you know, understanding how people mobilize their social capital and whether they have different access, different returns from their networks, and how this leads to cumulative advantage, disadvantage, is something that might be interesting to then use on this personal network-based world, right? So we can use the ABMs to also study processes that are not so much coming from social-centric networks, but from personal network analysis for the same type of things. And the last thing is that we can actually also use it to strengthen the theoretical basis of personal network analysis. I just had a coffee, so no. Sorry for that. Very often personal network analysis is based on these correlational analysis, so to speak. So we make some sort of assumptions then of how this correlation, what that means, right, in real life. And so these assumptions, we could actually sort of test them, right? We could strengthen that basis of personal network analysis to sort of make up for its, weaker points, maybe. So that's what we are trying to do, also in the Patchwork project. I won't talk about it too much because there's some people in the room who've already heard it so often that I'm sort of embarrassed to talk about it again. So, but this idea is that we are first doing empirical network research on personal networks and then use that information not only to analyze it statistically, but also to simulate societal networks. And then use that sort of the networks that we create then for empirically calibrated ABMs. So these are the people that are in the Patchwork project, some of them are here. Miha will talk about the simulation part. Jansap is involved in the empirically calibrated ABMs, and Nigel van Herwijnen as well. He's sitting over there, and he's a sort of shared PhD student at the Coalesce Lab and the Behavior Lab. And by the way, has a physics background since you were asking. I'll tell. But yeah, so this is it. Now a social science PhD student. Right. So, and then the idea is, of course, also that when we do these ABMs, that we sort of get new information that will also then lead to new empirical research with networks. So that's what we try to do. Why is this white? Yes, okay. Is this in the middle? Can I get this out? Yes. Right. So if we think a little bit about the type of networks that we're talking about, actually the networks, personal networks, are very, very large. And we see here a couple of these distributions of the degree in different studies. They're estimated at about 500 with a really large tail. Actually, the tail is the least reliably estimated, right? So people that have 4,000 could have 2,000 or something like that, but they're in the tail, right? So that's what we know. But as you can see, it's kind of similar across studies that we have these really large networks of people that we know as persons, right? And so, of course, that's going to be a little bit of a problem if you want to use that for ABMs, the large degrees. So we have to sort of scale down in one way or another. The second thing is the dynamics. So personal networks have been said to be really dynamic because we ask people, for example, who supports you, and then we ask about it 1 year later. And you name different people, but that doesn't necessarily mean that the relationships that you meant earlier have disappeared, right? They're just dormant, or they're not at that moment so important to you. But if we look at all the people that we know, we could actually consider them fixed at a not too long time period, right? So once you know a person, you cannot easily unknow a person, but you can go to a very low level of interaction with that person. So yeah, actually, you could sort of say that there's few people that you have strong relationship with. You see them daily, for example, and other people that you have only very few interaction opportunities with across time. Right, so rather than saying like, okay, the network changes a lot, it's more the interactions change, but the structure of the network might not change that rapidly as we tend to sell. Right, and so this is also a graph of Spencer and Paul actually adapted to weaker relationships as well. But where they said, okay, you have this frequency of contact and you also have sense of presence. So some people, you don't see them, but they're still very much in your brain, so to speak. So you think about them and so on, and you can pick up easily where you left at some point. And other people, they're just, you know, sort of nostalgia ties. You still know them, but they're not very important to you. And they're also not very frequent in context. The third thing is, of course, because of these different settings in which we collect the relationships, right? You have very heterogeneous ties. So you have the neighbors in your network, you have your family members, you have your workmates, and so on, all in the same personal network. This is Bernie Hogan's network, which he published in JOS, I think. But yeah, so it has this structure where relationships are very much clustered by these kind of contexts that we have seen before. And also, of course, each of these relationships can come with different sort of relationship norms. So the way that you exchange help with your family members is different than the way that you exchange help with your neighbors or your workmates, right? So there are some things that you can ask to family members that you can't ask to friends and so on. So it is a more heterogeneous sort of setting that we are thinking about. Right, and so we can think of that as different, well, the settings as the social foci that Scott Feld already mentioned, right, which can be organizational, so you can have your workplace and so on. They can be spatial, they can be your neighborhood, right? People are more likely to know people in a close distance, even though they also have relationships outside. And they can also be human, right? They can be friends of friends, for example, or one concept that I like is the kinkeeper, right? For example, my mother is a kinkeeper, so I hear about my family from my mother, basically, right? And then this is the way that I also keep my sense of presence of the rest of my family, because I know what they're going through, not because I talk to them, but because she's talking to them. So if you take the kinkeeper out, then the network sort of changes rapidly. And the last thing about these networks is that we have actually kind of rich knowledge on personal network mechanisms through this qualitative and quantitative research. So that's actually the point, right? So if you look at these kind of networks that we have, then you think, yeah, nice, but what does it mean, right? So what does it mean for the person? But there's a lot of qualitative research also on what it actually, how people deal with these networks, what goes on in these networks, and that gives sort of the life to the network. right? So there's support mobilization, there are relationship norms and expectations. There are also these strategies to adapt to the things that are happening, right? So if someone asks support, for example, from you, you can sort of obfuscate, for example. You don't have to give that kind of support back to the person. So there are different ways also to sort of try and adapt to that. Yeah. So that's the idea then, to sort of get information on this type of networks, right? This is the type of networks that we're working with, to gather this this data and then help use that for simulation and ABMs. And the first step is then to collect the data. So we're in that step, still in that step, because we had a huge delay with data collection. Yeah, the idea is then to also collect data that can help us with these different steps, right? So it's not just collecting data on personal networks, but also specifically to sort of improve the way that we can use them in the next steps as well. Which has some challenges as well, right? The first thing is, of course, structure. So we can ask people about the relationship between different people in their networks, but we don't know anything about, for example, the diameter of the societal network, so to speak. Of course, we can impose things that we already know from other type of research on this network as well, so that doesn't really matter. But yeah, that's one thing of where we are sort of struggling with. What kind of questions can we ask to really get to this structure? And the second thing is dynamics, because we have a cross-sectional survey. We do know that, though, for example, the frequency of contact, which is probably the main aspect in this network, right? That we can sort of, vary the bandwidth, so to speak. And of course, there's also other studies, like, for example, contact diaries and relational event modeling, where you can actually use that kind of information and put that into an ABM as well, right? Yeah, and the third step is the respondent biases. So we know that when a person responds to questions about their networks, they actually have different biases, right? So they don't remember everything. They might remember sometimes more than others, and so on. And so you have to account for that when you estimate things about the network, but also when you are using that information later to create a network. The second step is simulation. I'm not sure how I'm doing the time, by the way.
5 minutes.
5 minutes? Okay.
10.
That's good. 10 work. Right. Okay. The second step is then simulation. So once we have that information, then then we want to simulate this network. Michał is going to talk about that, but the idea is that it's actually already, there is some work being done, having been done in the past by others, to sort of see it as a missing data problem, right? So we have samples from the network, and now you want to create the whole network from that sort of perspective. And so we can use that information. Hi, I'm still, yeah, all right. And then the third part is the agent-based modeling. So for now, Yunsub and Nigel are doing, making the models, data yet, so we can't use them yet on those more realistic networks. The problem here is, as I said, the scale, and this is something that I think that Michał will talk about a bit more as well. There, but yeah, the idea being, okay, we have these really large networks. How are we going to manage that, right? How can we represent a network of millions of ties with 500 ties on average per node to something smaller, and do it in a way that we're not losing the realisticness of the reality of the networks, right? So to actually preserve the other features that are important to these networks. But that's a bit one of the challenges that we're working with. And yeah, that's the last part. So this is actually what we are trying to do. And then as I said, we try to also then generate new questions that we can then sort of test again. And thanks to the coffee, I'm already ready.
I count on the same effect of coffee on the question very fast. We have 8 minutes, so we have time for questions. Any question? Andreas.
Okay. Yeah, well, thanks. As you know, I really love this project. So I could imagine that one of the challenges you face if you want to go forward and then study certain social phenomena, like, for example, political polarization with this kind of data, that you also need to know something about, let's say, the different meaning of different ties to people. So
Yeah.
in some kinds of ties, you would discuss political issues, in others you would not do it,
Yeah.
depending on the norms of the context in which the ties are embedded.
Yeah.
In some sorts of ties, you would, even if you discuss political topics, you would not let yourself be influenced by this kind of person.
Yeah.
But in others, that's different. And do you try to theorize about that, or do you collect also information on that? So which kind of topics do you discuss with whom, and how do you perceive their role?
Yeah, exactly. Yeah, that's a good question, because of course, because we have questions on quite a few ties, we cannot ask hundreds of questions, right? And so, for example, one topic that we're looking at specifically is trust, right? How does trust sort of generalize in a network and gets to social trust? That's Nigel's project, right? So we do ask people, for example, who do you trust personally, and how is your trust in society and stuff like that. We do ask questions also on what type of relationship do you have with this person? Is it a positive, negative relationship, for example? Frequency of interaction and so on. But there is sort of a limit also on what we can do. So right now we didn't have questions on the political kind of, but we still consider that as a good question. Yes, that would be one of the most straightforward applications for others, I guess. Yeah. Yes.
Any other?
Yeah, very nice project, and I really like it. But there's one thing that I probably simply missed. But why do you need agent-based modeling for the large egocentric network? Right? What's wrong with focusing on a more core network? Or
Yes. It depends on your research question. So you can, at times, of course, you could say, okay, we're only interested in, for example, if it's about social support, we don't need to know about 500 people that you know, but we need to know about the most core ties, and then you can use them. But there are other questions, for example, trust and so on, where you're actually influenced by a wider network and not just by the core people in your network, right? And even social support, for example, it just happens kind of a lot that people do get support from people they didn't expect to get support from, right? So this is why we actually do want to sort of focus on the bigger networks. And then once you have the bigger network, you can always go to smaller circles within that network, but not the other way around so much, yeah.
Any other question?
I may also add some, because currently I'm also working on this kind of issue, especially based on some result of the under the assumption that there are so many people have lots of many acquaintance relationships, then something like 500 or something like. Under that assumption, and because usually many agent-based models assume the small world or something like structures, but they actually usually this very small net, literally something like 100 modes or something like maximum 1,000 something like. But when this kind of very complex structure of, in terms of degree distribution, it actually changed a lot, especially when very classic models of Axelos cooperation and DBO model and net sharing segregation is applied. In this context, actually, some results has lots of changes there. So actually, the implication is definitely something like some more realistic network structure consideration of this is very important, especially in the agent-based modeling conditions.
Good point. I would just comment and just with the PhD student group in mind, one of the things that I was reflecting when we were showing this kind of flow, right? That's sometimes people are asking why we need teams. We need to infrastructuring research lab, right, for doing social research when it's very easy to do it also alone. There's a discussion, by the way, also internally to our PhD program about this lab team-based kind of, and individual type of things. And someone would say, okay, so this is an example, in my opinion, about the fact that it's this kind of cutting-edge research about mixing together or imagining a flow in which some of the research here can then inform and guide you new design for data collection. This is something that can be done only if you build an infrastructure team. And in this case, also if you are well funded. But anyway, in general, I guess probably one thing that we share all around this kind of the institutes in which we are based is that we are building this kind of infrastructural groups that just to incorporate this kind of feedback, this kind of cycle of different methods informing each other, which is obviously the advantage to be in a team. Sometimes it's painful because you have to attend team meetings. I say my PhD students there, sometimes it's painful, you know, oh my God, we stay at home working on my paper instead I have to go to the BA teams and meetings and oh my God, but this is exactly the point, right? So you made a crystal clear example of the advantage of a team-based type of social research. Yeah. Okay, also taking a little time.
Yeah.
Okay. Any other questions or can we move to Mihail, right? Next speaker.
How is it like when you're out there, you're like.
Italian keyboard.
Now let's try to test your adaptive heuristics. Adaptive heuristics.
Adaptive agents. But I feel like I need this is like up to.
I've seen a crowd struggling with the Italian
I was like, I don't.
For 2 minutes.
ABMs.
No, sure.
You know, I was also feeling it when you were saying, I was like,
There you go.
like, oh, wow.
All right. Hello. I'm Michał. Thank you for having an opportunity to present my work here. I was trying to come up with a very funny acronym that will combine into TBA, which was the final of my presentation, for which I apologize. I didn't came up with a very nice example for that, but so yeah, forgive me. What I would like to present to you, so most of the say presentations start with a question. So I thought, okay, let's turn it around and let's start with provocative thesis so that we can have some discussion. So I'll provide some sort of an overview of the type of approaches we consider for the framework that Miranda described. So in that sense, this will be a great follow-up for the Jen's presentation, which was very interesting, and I think I will be picking up of some of the themes that she mentioned. So I'll start with the thesis. Sorry. So the two statements I want to start with is that if from the casual literature review in agent-based models, you can see that that's my kind of opinionated, exaggerated standpoint is that you can see that actually a lot of studies underappreciate the statistical network models, that in the sense that they could be used, but they are not used. So the question is, okay, are they not used because there are substantive reasons, or they are not used because we are still kind of not communicating between the different research communities well enough? So I will not answer that question, but I think that's one point for discussion. And then a kind of a related, roughly related statement, intimately related statement, is about the scaling issues, to which I will talk about which I will talk about a bit more detailed, and about which Miranda already mentioned them. And to put a doubt here, so whether if we have an ambition to study larger systems, larger social systems, so beyond the school class or beyond the village, is the network or the graph still a useful abstraction or a useful mathematical object to work with? Right. What I mean by that will be, I hope, become more clear later. So I wanted to start with a little bit of background, but Miranda already provided a lot of that. So the general framework in which research questions we are interested in the project revolve around relational cohesion, and especially the relational aspect of of social cohesion. So the social relational aspect of social cohesion. I think if you look, so of course, this is cohesion. Social cohesion is a concept which shares lots of features with the concept of social capital, especially the difficulty to identify, to define it, right? So as some say, this seems like a little bit like pornography in a sense. Nobody can define it, but we know it when we see it. So, and people work with social cohesion. Break it down in these approaches to social cohesion in the sense that we understand social cohesion that is something purely in the structure, in the social structure, right? So we have cohesive structures. So in that sense, there are network properties related to social cohesion. Or sometimes you can think about social cohesion as something that happens through social structure, or maybe I was looking for a proper word here, but so I was thinking it's like that it's coincidental with social structure or co-evolves with social structure, right? So there are social processes that happen within networks that make a group or a society more or less cohesive, right? So in terms of structure, we think about these properties like segregation, segmentation on granularity, which I essentially think of as segregation, but without having an observed attribute related to which the segregation happens, clustering or transitivity, right? Or the lack of centralization. So in a sense, we think of often when we think about a cohesive network, we think about a network in which everybody is more or less equally connected with everybody else, right? So in a sense that there are no hubs. And in terms of processes, so okay, when do we think about a society? When do we think that society is cohesive? Well, society is cohesive when we have people cooperate with each other, so there is no cheating or rewriting. There is no polarization, or there are people help each other or support each other, and so on and so forth, including something which the European Commission, of course, likes in recent years, namely that the societies are resilient. So this is a term that comes from, I believe, thinking of, say, infrastructure, right? So to what extent the infrastructure is resilient in the sense that what happens if we blow out the power plant and so on and so forth, will everybody survive? So we can also think about resilient societies in the sense of, okay, do people have uniform access to social resources like social capital, right? Or again, following up on the infrastructural ideas, is there any kind of redundancy in social structures in such a way that if something happens, the society will still be able to function? So this is essentially a consideration of the basic workflow that Jan already talked about. So I will not explain it in detail again. But in other words, I wrote it here not in three steps, but in 4 steps. But so we have the collected data. Then we want to use the collected data in order to fuel, to construct an empirically calibrated social microcosmos, and use this microcosmos as a kind of a laboratory object, if you will, right? So that we can study all sorts of social cohesion relevant processes using that social microcosmos. And this the 4th step, which I have here, is Miranda already had in this 3rd step as well. So in a sense, if we use ABMs to study them in the empirically calibrated social microcosmos, and we imagine doing that, for example, based on the data from different countries, I would argue that essentially we turn an agent-based model into kind of a measurement. In what sense? Well, in the sense that if we use, say, kind of a public goods related model, for example, then we can ask ourselves, okay, which of the societies through the networks are more likely to produce cooperation, right? So whether people in network structures likely for a particular society are more likely to say contribute, for example, to solving goods, right? So in that sense, an ABM outcome produced by in a particular social macrocosmos measures some aspects of that particular microcosmos. So this can be analyzed both on the, say, macro scale under countries, but also maybe group level. So if you say analyze migrants versus natives and so on. So I want to focus on item 2 to understand what kind of approaches there are to construct that empirically calibrated social microcosmos. So again, provoking a little bit, you can ask yourself, okay, but do we actually need that microcosmos, right? So everybody, the whole world experienced COVID. So maybe we can just simulate the society into one-to-one scale, right? So this is a screenshot from the COVID pandemic model that was developed by my colleagues from University of Warsaw. And this was a model that was created in a one-to-one scale. There were 37 million agents, right, distributed across the country according also to the census statistics, and lots of other things were built into it. So there was no network. The object that they worked with was essentially agents in space, but included all sorts of complexities, including things like people traveling between the cities in trains in the compartments of 6, which makes them more likely to get infected. And the trains traveled across the country according to the actual schedule. Right? In that sense, you build all the realities that we know about into this in silico system. So another question that I would like to pose is that, okay, can we work with on these topics on the one-to-one scale? And of course, maybe this is more easy in the, say, health-related or the problems or transportation problems, in the sense that you can argue that the official registers contain all the relevant information that you need. While we ask sociologically or social scientifically relevant questions, actually these official registers are often void of relevant relations, right? So we need sources like surveys through which we can learn about social structural relationships in particular, about certain weak ties, through name generator type of tools, or aggregated relational data. Of course, the downside of that is that these are samples, so the right samples, they are not exhaustive, and they are often self-report. So it's again related to the biases and other things, problems that Miranda mentioned. So in that sense, while in some settings, maybe you don't need the microcosmos because, well, we can build it on a one-to-one scale. In sociologically relevant context, I would argue that, in fact, we unfortunately need the microcosmos. So we need something more synthetic. Right? So now the question is, of course, the how. This is a very short list with some example applications, which is far from being exhaustive. In that sense, I really look forward to what you do in your projects. That's a very interesting endeavor, I think. So if you look at how researchers try to represent a social structure in agent-based models, as we already said, people often use 3 most well-known theoretical models of random graph distributions, I should say. There are often ad hoc algorithms in a sense. Okay, let's start with some model, say small world, and then let's tweak it just because I want to chase this macro level property that this model cannot reproduce. and this chase is often very ad hoc. Right? And you have some other approaches. And finally, you have a somewhat separate array of methods, like exponential random graph models, the error-related hybrids that actually Miranda also already mentioned. So this is work by Smith and Barrow, so in the sense that try to inform ergons using ecocentric data in order to build this data set, which we actually kind of now are much wiser in the sense that we know how to fit ergons to ecocentrically sampled data. And of course, if we are interested in not in a static picture, but in a dynamic picture, you have sums, terms, and other variations of these models. So I've made this kind of a contrast, again, exaggerated in all sorts of ways. But I would argue that what separates these two approaches is that these things we can fit to empirical data. And it's not that natural to feed these things to empirical data. You may ask why. Why does it matter? I think it's an advantage. Actually, that might have all sorts of advantages. So we'll be talking mostly about ergons because that's the kind of territory that I'm more familiar with than these other territories. But I think that similar points can be made also for sounds. So I would argue that these models, like the ergons, have relatively well-studied statistical properties, including ergons because they are parts of exponential family distributions. So in that sense, among statisticians, these objects have a well-known property. Because ergons, for example, have a wide variety of terms. So it says you can build the distribution, random graph distribution, using very different sets of parameters. And if you're interested in in constructing a family of, let's say, ergon distributions, that will vary, for example, the centralization or degree variance. You can vary such things systematically in the sense that there are terms that will come with associated parameters, and you can vary the parameter in order to vary certain properties in a systematic way. So a lot of agent-based models, ABM studies that use networks that study some sort of process on the static network actually do exactly that, right? So in a sense, for example, we want to know how polarization will be affected by the small worldliness of the network, right? So in that sense, we can build an ergon in such a way that will be these kind of properties can be varied in a systematic way. So in that sense, it can be relationships between structural properties and ABM outcomes can be more readily studied. The third point I wanted to make is maybe even the most important one. Namely, there's a growing empirical literature for in which these models are fit to real data. So, of course, the goal in these studies is that they want to identify what kind of structural properties a particular data set has, right? But as an ABM modeler, you might say, let's do it, take it upside down. Let's use the published results to simulate the networks. And with things like ergons, you can effectively take the table of the results from the paper, assume some distribution of, say, node properties, and start simulating networks right away. Right? So in that sense, for example, if we want to have networks that look like friendship network in a school class, we can take a study, and there are lots of them, right, about school classes, and establish a distribution of networks such that the observed network will be at its expected values of the mode, right, around it, so that we can simulate networks that move similarly to the one that is observed. The next point is that, well, if we have such a model, they are substantially interesting in the sense that these parameters of these models have good interpretations, right? So this is maybe not directly relevant if you want to just grow the network, but it's still nice in the sense that you work with a model that has direct interpretations. Actually, I've maybe said the last point. So the second to last point is also important in the sense that ergos in particular, you can fit them to the data, so you don't need substantive data to be able to estimate them. So we have developed methods by which it is enough to know a collection of some properties, and you can then try to estimate the model in the sense to build a distribution that will have of networks that will have these properties as will meet these properties in the expectation. So in particular, we have methods that it can be. So there are methods that can be used to estimate an erg based on egocentric data. So personal networks, just like Miranda described. So in order not to just talk about what's possible, I wanted to show you that something is possible. So for example, these are the erg results fit to the 1,200 personal networks collected in Poland a couple of years ago. So this was not a particularly complex model, but as you will notice, it was a diet independent model. So the only effects that we have here are effects of various demographic attributes and homophily in them. So in that sense, the parameters of these models, which are here described, so there are 3 models here, can be really interpreted in a sense that, okay, how strong homophily is depending on age and so on and so forth. But then can be used to actually simulate the network such that it can be used for ABM purposes. And not only simulate one network, but simulate a distribution of networks consistent with the data. So that's the first point I wanted to make. And then the second point I wanted to make refers to scale. So in this network, as you will notice, actually the degree distribution, the average degree is rather low. And so these are based on the core discussion networks. So people on average have 2, 3, maybe degree of 2 or 3. So the reality changes if we look at weaker social types, of which people have much more. So this is a distribution that has been estimated using the network scale-up method based on the Spanish data. That's Bridges project that Miranda ran a couple of years ago. So this is another one to the collection that Miranda had on the slide. So apart from the shape that may look familiar, apart from the bump, which is a different story, the median number of acquaintances is 450, not 2 or 3, 450. So the question is, okay, can we use the same approach like here to essentially estimate and then simulate networks of that will have that properties? So of course that's the question of size. Of course we cannot. It's not feasible to simulate such networks of the actual size. So for Spain this will be 47 million nodes. Probably not. So the question is, okay, can we downscale that some way? So is it feasible to make a system that will not have 47 million nodes, but say 10,000, 100,000, that will be manageable, but still preserve the key properties? So this refers to the problem of scaling, because of course there is no one way, more than one way to do that. you can argue that most social networks scale in such a way that as the network grows, the average degree stays constant. So this is an example of the school data collected in Poland. So these are school classes of different sizes, and you have average degree, out degree, that's the case on the vertical side. So you can actually see that whether you're in a class of 11 or of 30, the average degree in that network stays the same. So it's a problem. Why is it a problem? It's a problem because of this simple formula, right, which relates the density D, the edge set, the size of the edge set, and the size of the vertex set. And this first term is the average degree, assuming that the network is under. What does it mean? It means that if you want to work with a system of 4 discussion dice, so that the average degree is, say 4, right? Then if we want to simulate network of size 100 and keep the average degree, we will get 200 edges and the density of 0.4. And this will be larger for if we want to simulate a system of 10,000. Still preserving the average degree, right? The same. So you can think of the question is, okay, so what kind of research questions then are we answering if the microcosmos is created in such a way? Right? Well, you may argue that it's a question of, okay, how would the core discussion network might look like in a town of 10,000? So it's not a miniature of the country, it's a miniature of this is a small town. Maybe it will be more pervasive actually if we think of do the same kind of a simple illustration for an acquaintanceship network. So if the average degree is 700, the median was for 50, the average is around 700, then, well, if we want to preserve the average degree, we need to start at least at the size of 701, because then we'll build a complete graph. Everybody knows everybody else, right? Again, let's think about the research question that might be relevant here. Let's imagine a town of 700 people. This essentially means that it's very likely that everybody will know everybody else in that town. Is this a good system to simulate Spain as a whole? Probably not. So the question is, should we scale down Spain in such a way that we preserve the average degree, or should we preserve the density, right? So do this, in sense, look, not the average degree. So is it break this empirical relationship? Try to preserve this other property, right? Of course, the reason is that if we grow the system such that we will still be able to incorporate all the variation on, say, for example, people's characteristics, so to say 10,000, we're getting astronomically large networks, which are actually infeasible to work with. Right. So this is the problem of scale, right? Of scaling up or scaling down. So the question is, so which direction should be taken here, or maybe a compromise? How this should be derived based on this. And I would argue so which properties of the network? This again goes back to the points that Jen made earlier. If we have a relevant social process on the table, be social influence, or maybe pandemic, which of the two extremes are more important for the outcomes? So I would argue that for a lot of, we know that maybe for empirical or for academical processes, but much less for socially relevant processes, namely how do ABM outcomes scale up and scale down with these properties, right? So with network size and with density and average degree, right? So in a sense, if we want to simulate a particular socially relevant process on a smaller scale, how should we build this smaller scale in order to get still credible results? So I'll finish with some caveats, namely, I described ergos as a kind of a panacea for all these problems. They are not. In particular, most of these terms that were created for ergos, of course, the list is infinite, but basic 250 is already kind of implemented in the study. They are mostly about local properties. But then, in fact, it seems, this is something that's not very well studied, but it seems that if you want to build in properties that summarize macro level properties, so for example, average distance, something like that, the ergos actually collapse in the sense that it's a property that is prone to abrupt changes among adding and removing ties, that you get so-called degenerate distributions very easily. But this is a lot of scenarios that have not been studied, so it's another caveat or point of discussion is that if we say have empirical information on some of the properties, but let's say we don't have empirical information on some other properties, but we know or assume or expect that they are important, what should we do about it? So ergos ignore that in the sense that ergos are maximum entropy models. So in that sense, they try to be putting independence and uniformity wherever there are no empirical information. So the question is it acceptable, or should we rather use some theory to add a parameter and vary it systematically, right? Just because we know that there is clustering. In fact, that we know that there is a community structure. That's why I asked that. And finally, if these networks are so large and so cumbersome to work with, do we actually need networks of 700, average degree of 700 at all? This is rather a better scenario to work with a kind of a Blau space in which we encode all these proximities, social proximities in a space. And of course, there are some methods, models to do that. It's not established whether they can be estimated with personal networks. That's something that they research on. And I'll leave you with that and the giants.
You 2 minutes for questions.
I'm wondering about the scale. I mean, I have one question about ego networks, but that's us. I will talk about later. But I'm wondering about the scaling, though. I wonder if you have a smaller group school class and a bigger school class, whether you systematically have the same patterns just repeated in a bigger way. So whether you say the degree is the same, okay, even if the degree is the same, it doesn't mean that, for example, the multiplexity will be the same. So that, for example,
Or sensitivity or
yes, but so to take the multiplexity, I have more choices now. So I can go for my social support with one thing to one person and my social support to another person. Whereas if I have a smaller group, I will overlap that and there will be more multiplexity there. So, okay, with the degree, that's one question, but the other question is what with other aspects of that? I also wonder if you have bigger groups, if they're not a dynamic at the group level that's placed, that basically people become having specific roles in a group. Like, you know, this is something that could be a group dynamic, not just an individual thing. That's, you know, I become this person, I become that person. And the bigger the group is, the more you have to differentiate. And I'm thinking a bit about block modeling, for example, where you talk about roles that people play that will be different in small groups than in bigger. So that's the type of things I wonder about, that whether we can do that with ergos, also with whether we can do that with agent-based models. So whether we can do things like block modeling or try to, the type of things that block modeling tries to generate, whether we can do that with agent-based. So that's.
so maybe I want to clear enough.
Okay.
I'm sorry. So the degree was just an example. Yeah. Actually, you can build the same kind of an argument for all the network properties that are out there, right? And try to get a grip actually what happens with transitivity. So what's necessary for that is also isocentric studies that collect data about other outer ties. So there are lots of details actually that are not so easy to handle. So of course, if you move on to the even more complex matters like structures and what follows, I think is compounded.
Okay.
Yeah. These are compounded problems.
Federico, short, please.
Yeah, I mean, it's not even a question actually, but I was very intrigued by the idea of the, Blau space or weak ties. I just wanted to ask you if you wanted to tell us more, but I don't know if we have the time.
Or you mean
That's
How? I mean, yeah, maybe it's not the appropriate question for such a short amount of time.
yeah. So these are the so Hofrachter is probably some people are aware of that. So that's the first publication about latent space models. In a sense, we have nodes. If we have sociocentric data and then try to estimate locations of the people in this larger multidimensional space, such that people are more likely to have ties that are close to each other in that space, right? And McCormick and Zhang, it's a publication that tries to take these ideas to the larger networks. So they try to essentially fit models like that to the aggregated relational data. So like the data structure that is used in network scale-up methods. So for those of you who don't know, maybe that this is the kind of data in which you ask people how many people they know from a certain set of subpopulations. But as that, there is
I guess probably Federico was attracted by the Blau.
but
Yeah,
Blau thing, yeah.
more on that part.
I know it.
We'll talk about it later.
okay.
Yeah, but anyway.
Sorry.
Okay, so thank you. Yeah, thank you. So we have the last presenter for this session. Before coffee is Christina. So
Did you download it?
wait, okay. Oh. Nice.
That one. Sorry, I think everybody called it Milan. Ready for the picture?
Yep.
You will be, yeah, anyways. So good afternoon, everybody. Thank you. My name is Christina Chocaro. I'm a research associate at Durham University working with Jen, but today I'll be talking about my work on the echoes from social media platforms, which follows on the discussion about polarization started by Andreas, and also with a focus on echo chambers rather than polarization as such. That was the overarching theme of my PhD. But also I built a theoretical agent-based model, which is different from Christoph's empirical work. So we'll see like how everything comes together, hopefully. So let's start it. I'll start providing a research background before moving on to the model implementation and some preliminary results and future directions of where I want to go with this. So polarization, a new topic for today's workshop. That was very popular, but I got the headlines. So yes, so it's not a new subject, but it has received significant scholarly attention to the point that the concerns about polarization have spilled over to the media, with people becoming increasingly divided, not wanting to talk to each other, and this is getting reducing social cohesion. But before we can get worried about polarization, we need to conceptualize it, and the way I do it is by taking DiMaggio's colleagues' definition, whereby polarization can be both a state and a process. So as a state, it represents the opposed opinions in relation to some theoretical maximum. And we can look here at the 2014 graph, right, where we have large proportions of the population in the US feeling either Democrat or Republican, with fewer people in the middle. But we can also think of polarization as a process, right, which refers to the changes of those opposed opinions about an issue over time, what we see in 1994, 2004, 2014, and more recently. When thinking of polarization, we also need to think about the context in which this is happening, besides the networks. We need to look at social media platforms because they have become increasingly important for our everyday discussions, not just keeping in touch with our loved ones, but also They're the source of our information. And here is where two connected but distinct concepts are relevant, namely the echo chambers that everybody has heard about in a different context, and filter bubbles. So echo chambers are those enclosed media spaces where like-minded individuals share primarily information that will support those groups. So it's about the people, but also the content that gets shared in there, which reverberates through the network. And Jen put it very nicely earlier. It could be like talking to a mirror where you get back what you put out there. Filter bubbles, on the other hand, are different because these are the personalization algorithms that are inbuilt on the platform. That what they do is that they bias the content that you would receive towards information that would agree with you. Because let's not forget that the goal of social media platforms is to keep us online, to keep us there engaged. So they will feed us something that would trigger our engagement, and sometimes information that disagrees with us, just so we keep scrolling. So the question that I put forward is, how do these echo chambers emerge? Because there's an ongoing debate in the political science literature that questions their existence or even their prevalence when it comes to like contributing to polarization, right? And we see the headlines. But what I'm interested in is what is the role of social media platforms, these filter bubbles, but also social network configurations, because at the end of the day, it's both the people and the content. And this is part of a larger model that I designed for my PhD, where the aim was to understand the interplay of both social networks, we see here at the bottom, and social media platforms on the top. But the focus this time is on echo chambers, right? We have two key mechanisms. With social networks, we can think of how homophily would affect social influence, because people that we deem similar to us would tend to reinforce our views, and in turn would affect national identity. My motto is contextualized in the Catalan secessionist movement, which has been an ongoing movement since 2011 in Spain that has divided the Catalan and the Spanish society on the basis of national identity. So people have had to choose, do you feel Catalan or do you feel Spanish, or more in between? And the two mechanisms are social networks and social media platforms. So let's get into the actual model. So following the tradition of opinion dynamics models, my agents are people with bounded rationality, so they only act on the information they have. And the the population of my model follows the sample size of the Catalan Center of Opinion Studies, which is where I draw the distribution that you see here of Catalan and Spanish national identity. So we see at 1 that there's a larger number of people that feel solely Catalan. The people that are at 0 are feeling equally Catalan and Spanish. And these are the two polar opposites that we can think of when we think of polarization. And then at the bottom, we have at the -1, the people that solely feel Spanish. The attributes of my agents are, of course, national identity attitude, ranging between -1 and 1. And then the uncertainty parameter, which is very common on opinion dynamics models. But in my model, instead of being a fixed parameter where every agent is assigned an uncertainty, here it's drawn from a random distribution to capture the fact that not every person is equally persuadable or likely to update their opinion despite of the similarity. So we're seeing that more people are more gullible or keen on updating opinion, where others would just stick to their guts regardless of what you tell them. The other parameter that is relevant here, since we're dealing with networks, is engagement, which reflects how engaged and keen are people on social media platforms to share information. Because we see that, again, it's also drawn from a random normal distribution. We see that some people are overly active on social media, like your influencers, so constantly bombarding people with information, whereas the large majority are just lurking around. You just want to hang about. You don't want to actively engage. And this will have consequences for the distribution of opinions. What's the environment? It's a weighted multi-layer multiplex network, which is a very long way of saying that we're representing the same individuals into different contexts, namely the offline world, like we're currently here, and then the online world. But what I've done is I've also assigned a different topology to each of these networks, because it's not the same as offline networks. Something is, sorry. So that one follows Watts-Rogat's small world network, where the average degree was scaled down from Miranda's work in Spain, because again, we're contextualizing this in Spain. It was scaled down because of the density problem. So I'll be happy to comment on that, because that was a reviewer comment, but we can pick this up in the coffee discussion. And then the online layer follows a Barabasi-Albert scale-free network. And again, the average degree was scaled down from Dunbar's work. And if you've noticed, besides the different n, we see that node A is missing. Why? because not every person has access or use the social media platforms. So we need to account for that disparity, because those people, think of your grandparents or even some of your parents or people that just refuse to be on social media, they will not be directly exposed to the filter bubbles or echo chambers. It's the information percolating through the network that will be responsible. So it's a different way of capturing that underlying process. Now let's get into the two agent decisions. First one is information diffusion, which is a distinct process from opinion updates. So on this one, because again, we're dealing with social media platforms, we have two different filter bubble scenarios, right? One, where we would receive random information. So it's an equal probability that the information you get exposed to online, if you have an online tie, you would get a random information that will support or disagree with you. Whereas if you have a filter bubble on, following the existing literature on it, you will get primarily information that agrees with your views, with the idea that it would eventually reinforce them. We will see if that's the case. Say that you've received that information, then you ask yourself, what are my engagement levels? Because again, you could be a lurker where you're just chilling there and you don't even want to share the information, but sometimes you feel like, you know what, I'm going to share this piece of information. So you first compute the difference between your national identity opinion value and the informations. So that's the traditional bounded confidence idea to compare the similarity with if it's within a threshold. But then this is where we look at each other's networks. Because when you're online or even offline, you don't just look at yourself, you look at will the people that I'm going to share this information on Twitter or on Instagram, on Facebook, can agree with what I'm going to say? So what I do is I do a group homophily calculation, checking how many of my neighbors would be in agreement should I share this information that may contradict the majority view. Because it's also a way of seeing if I'm in a majority or a minority. And I'm implementing the spiral of silence by Noel Newman, which tells you that when you believe to be in a minority, you will refrain from sharing information that will contradict that. But I still felt that we needed to account for those instances, because say that you're feeling super Catalan, but like somebody says something that is less inclined to that, you might be too upset by that response, despite of being super disagreeing with you, and be like, you know what, I'm going to share it to all my friends because this is unacceptable, for example. So this percentage is 20% of the time, and I'm currently doing sensitivity analysis changing. Okay, so now we've shared the information. How do we actually distribute information? Again, we have two different layers, so we should follow two different communication regimes, and it's inspired by Marine's work of one-to-all communication if we're online. Like if now Flaminio tweets about this talk, all of you who follow him will eventually see it. So time is abstract in this model. I hope you took a good picture of me. Like otherwise, yeah. Last time I was like this. So yeah. Anyways, if it's offline, what we would do is that an agent will select another of their neighbors to share one-to-one. So again, we have different diffusion processes through different mechanisms. Now we've received that information. Again, that's on one side. Now let's move on to our opinion update, or national identity in this case. If we receive from the media, we do the traditional bounded confidence where we calculate the distance, and if it's within our similarity and we feel that our certainty is sufficient, we'll get persuaded, right? Thumbs up. We get a simulative influence. But what about if we get information from a time? The things change because we would take into account the social influence. We would take into account who sent that to us. And this is where we're allowing not just for positive assimilative influence, also negative, right? The repulsive influence, but also influence that will persuade us against our original opinion. So instead of going towards the extreme, we might actually be persuaded in favor. Because say your mom sends you information about flat Earth. It's not the same that if your colleague is telling you information about flat Earth, like who cares? But if it's your mom, you might actually take a second look and be like, you know what? She might be right. She's not. Just put it there. She's not. But this is the sort of process. What happens when we take all these things into account? That our group homophily changes. So say that we're shifting our own opinions about national identity and picking a side, perhaps, or remaining there, the group homophily of how many of our neighbors are similar would change. So that would have an effect on the overall dynamic. Now the measurement of echo chambers. So what I'm measuring here, and again, these are preliminary results, is the proportion of similar others within one's online network. Because again, echo chambers is the online only exclusive thing. But what I'm measuring them is over time, because the assumption usually is that when we take social media data, we take a snapshot. We take that moment and say, oh, there's echo chambers, or oh, there's no echo chambers when we ask those people in a survey, or we follow. So we follow them here, because that's one of the advantages of ABMs. Some people, so that's why, because it's a network measure, we take the network measure approach as some other people have done by looking at the density, because the higher the density, the more likely you'll be to interact with people that are like-minded. We can also look at associativity and clustering coefficient. So what we do is I created two different initial social network scenarios. So keeping the structure of that multi-layer, multiplexed, beautiful network, we start with different group composition. So on the one, we have a random one. So node I is the center, right? And it's connected to these 6 people. And we see that orange is, well, you don't see the legend, so you have to imagine. Like blue is feeling Catalan and orange is feeling Spanish. So here they're in a diverse network. But when we start from a homophilous network, we're embedding those people in a homophilous cluster, right? People that would agree with you, because we see that there's like a large majority, like 1, 2, 3, 4, 5 out of 6 neighbors are in favor. So starting from a different initial network, does that make a difference for echo chambers? Because we're basically putting people in echo chambers. This is only applied to the online networks, not the offline. Again, and we see a different number of online and offline people. But as I said earlier, echo chambers are not just network measures, but we also, because the structural properties don't tell us about the content. Yes, it's telling us who you're connected to, their opinion, but what do these people talk about, right? So what I created is 2 different social media scenarios, because let's say that we're feeding these 2 initial network setups. One where individuals are getting diverse information, right? Information that agrees and disagrees, but another one where they get information that agrees and disagrees with them. Would we see a difference? Again, is it about the network or is it about the content that gets spread in the network? These are beautiful spaghetti plots. So let's do top row, bottom row, like just to explain it. So on the top, we have the random social network scenarios. And from left to right, we have filter bubble off and filter bubble on. So what we see is that when individuals are in a diverse social network, like the top left corner, and they're getting exposed to information that agrees and disagrees with them, the people that are on the extremes, there's the little pointer. There we go. Perfect. The people that are on the extremes, right? The people that feel solidly super Catalan, like they're slowly converging towards the center, because although there was a greater proportion of people on the extremes, they don't have sufficient people that would support their views, but also they don't have information that would also reinforce their views. So that is what Andreas was showing earlier of, like, depending who you speak with, if you have interactions with people that are different to you, that might decrease polarization. And in this case, we do see some convergence with like thicker lines. But what happens is, again, if we're in a diverse group of friends and we have information that would support your own views, we do see that convergence, but we still do see plenty of people that were on the extreme that may have initially converted towards the majority, but they still maintaining their opinion, so it's not really as effective. The picture changes quite drastically if we look at the bottom plot. Although they might seem similar in principle, you can see that, again, if we're starting from a social network of a primarily supportive people, but information that may agree or disagree with us, we may have a slow initial convergence, right? Like these people are shifting slowly, right? Again, time is abstract, but they're still not converging because they still have a network that supports their views. So they don't have an incentive to shift in the majority because they already are in a kind of majority. But my favorite scenario is this. The homophilous social networks, so again, we're surrounded by similar others, but also information that reaffirms those beliefs. And I hope you can vaguely see this, but it goes on like that. So we're not seeing bipolarization like the original bounded confidence models, but rather like the people that were originally on the extreme feeling solidly Catalan and the people that were in the center, they hold their positions. It's these people on the center that are shifting their opinion because they are between both sides and they're being asked to pick, right? Because they feel a little bit more Catalan than Spanish, but not sufficiently to feel only Catalan. But still, we do see plenty of people in the center. So we're not seeing that dramatic picture of like everybody's polarized, nobody no longer talks to each other. It's more like a nuanced shift in that favor. Now let's look at the same plots, but our echo chambers measure. we got this interesting plot. So, like I said earlier, when we're in a divided, well, in a random social network of mixed views and information that is also diverse, we will see that most people converge to the center. And this curve is the opposite. So, like as if I flipped it over. So how can it be that we start with 30% of all our online social media agents in an echo chamber? As people are shifting in favor of the majority, they still have the same networks because we don't have rewiring in this model, but because most of their friends are shifting towards a common opinion, the echo chamber will increase because suddenly the same people that perhaps earlier were not sharing your opinion now are. So we see an increase. But like I said earlier, if we introduce the filter bubble on, we see that it has a moderate effect, like nothing like that, right? The super strong convergence. Because initially some people do shift, like I said, the people on the extreme, but they still are receiving information that agrees and disagrees with them. So it's not sufficient to like get everybody surrounded by people that would agree with the views. You see something, but not enough. The more interesting picture once more is this one. Again, because we're in a homophilous social network, we have a very high proportion of people already in an echo chamber, right? Like 6 out of 7 neighbors, to use the same graphic, although it's not the exact same number, are already supporting your views, right? But you get information that is from a diverse source. Again, we see that at the start, we see a slow convergence despite of the very high echo chambers. So we see a dip, but again, it's not enough to persuade us in favor of the majority. So we still remain in our highly homophilous clusters because most people have not shifted their attitudes in favor of the majority. This one is the strangest of all, but not necessarily. Because again, we're starting from a homophilous social network, right? And people are receiving information that supports their views. So we already have a good 80% of people surrounded by similar others. But what happens? That opinions are not staying constant. So, like I said, the people that were on the extreme, right, solely Catalan, or the people that feel feeling equally Catalan and Spanish, those people are holding on to their guts, right? But it's these people on the 0.5 that are having to make a choice. So if they're on the fence about whether I should side with either of the options, whenever they are starting to make that choice, they are no longer within a homophilous groups because they're slowly becoming the majority within their own network. That's where we're seeing this drop, and it keeps dropping, right? Because again, you're still keeping the same friends, like your high school friends, but then you grow up, or in this case, you change political ideas, and yes, you're still friends, but you no longer can relate to them, right? If we're looking at national identity similarities, so that's what we see this drop. So now the next question is, well, first the implications, but I'll go to that in a second. The next question is, would the proportion of echo chambers change if we implement rewiring? If now these people that have become a bit polarized, right, that have gone to either solely Catalan or more Spanish than Catalan, if we give these people the opportunity to choose new friends, will they still choose to be in homophilous clusters? So will we see more people in homophilous clusters, or will we not? But also, if we change the homophily composition again, because it was quite high, will we also see first the same dynamics, but secondly, the same proportion of echo chambers? And lastly, like we need more realistic social networks, because again, we do have different topologies, which as we've seen already in various presentations, the structure of the network does matter. So I want to test that further. And I'll go through the implications. Sorry, I still have put in the other way around. So network configurations affect the polarization of national identity, but it's the presence of social media filter bubbles that promote the attitude polarization. And also echo chambers are inconstant. So we need to look beyond our traditional conception of echo chambers and what do they mean in this context. Thank you.
Thank you, Christina. We have 4 minutes for question. Christina, yeah.
You cannot be possible, that's fine.
Any question?
Okay, if nobody else wants. I'm not sure whether I asked this before, but I'm still trying to understand how it works, that if I understand you correctly, you do have repulsive dynamics in your model.
Yes.
At the same time, if we have stronger degree of echo chambering, so to say, we see more polarization, which to my intuition sort of is contradictory, because the exposure, so to say, to foreign attitudes you don't like, would actually make you more extreme if there is repulsion going on.
Yes, but see, that would make you less extreme in a sense. We see that even with our homophilous network, right, what you're saying about more echo chamber proportion in this one, and filter bubble. So you're getting exposed to diverse views, just perhaps not initially through your networks, but again, this is only online. So you can still get through your offline networks that information that would disagree with you, right? So, but again, in this one, we have a diverse media feeds. And you see that the people at one are slowly shifting, but don't get below 0.5. So you do see that reduction, right, in polarization towards conversions. But again, it's still not enough because they have that assimilative influence, right? That is like they are within a group. So nobody's challenging the view, even if they're getting information. Because I still feel like it's the combined role of like who is sharing that information and the content of that information rather than, but again, like these are preliminary results that I still need to explore their scenarios. So I'll need to give it more think, but thank you. Yeah.
Interesting. I'm not sure I answered everything, but how sensitive are these mechanisms for noise, right? So those the real life algorithms are probably not purely deterministic, right? There's some chance that the filtered bubble is on and off at times.
Yeah, I think that's a really good point. The point that I was trying to make with this research is how much do each of these mechanisms matter, right? Like, do we see a contrast in the first place? Because some reviews did suggest like implementing other filtering algorithms. So, but again, I feel that's going to come later in the stage because I feel like there's already an initial distinction. But again, could it be because you're getting more, like a larger proportion on the filter on? Is it the proportion that you're getting? The same thing I said with the echo chain, with the social network, is it the homophily within the network? So I feel like this is already pointing in that direction, that there might be something there. The question is how much more can we go deeper and explore that? But again, this is theoretical, perhaps with complementary to the empirical network, that we're not seeing that extreme polarization, but things I will consider.
Last question from Philip.
Okay.
There was you first.
So my understanding is just clarify this. So especially the first case, the filter bubble off, it seems like the reason why the people actually some interact with diverse people. I mean, in terms of because filter bubble off means everyone randomly interacts with the.
No, filter bubble has to do with the information agents get given, which is different from like the random social network, which is who are you friends with? Are you in a diverse group of people? Are you referring to like the group composition or the information you're receiving? Just so
my feeling is filter bubble off means actually everyone has the same chance of interacting with the same types of information.
No, I think everybody has the same. It's drawn from a probability distribution, like so like I think every agent will have the same probability.
I can explain why they converge.
Yeah, so that means actually social network structure can be much more stronger under the context of the filter bubble.
Yeah, that's the point I was trying to make, especially with homophilous one. But again, it's not as extreme as previous models have shown. So it also calls for like more exploration, because again, this is still abstract, like with caveats, and obviously we need more data to inform some of the parameters, but
Yeah, I mean, I feel like actually filter bubble on is a really interesting result, but filter bubble off sounds like actually it just increased the effect of homophilous social network.
Yeah, like you see here, but not enough to create that strong polarization. You see like plenty of people converge towards the center, but the ones on the extreme don't really have sufficient information. Alone is not enough. It's who you speak with, so, but again, that's what I was suggesting, that we need more network research on that matter. Is it again the structure? Is it the number of triads? Is it like the assortativity within the network? Why is it? So I feel like if this is pointing us towards next questions, to me, I'm happy with that.
That's the final question. Sorry, it sounds like actually also my understanding is very theoretical. I mean, which means it's actually has an implication of a general models of social influence and opinion dynamics, but why it's more actually has a power of explanatory power for the case of Catalonia independence.
Well, I'm not trying to explain what happened in Catalonia. I'm trying to explain how could we observe the dynamics that we do, given this constraint. It's just a possible and plausible explanation. I'm not saying this is predicting the survey data. If it bears similarity, this kind of plot it does, but I cannot just go and claim like this is it. That's all you need. If that's 3.5 there, you're sold. You know, like that's not what ABMs are, I think are for. Like, so I'm cautious. Yeah.
Okay.
Coffee break.
Coffee break.
Thank you. Oh, thank you. Yeah, but it was basically like just Miranda's ticket.
Yeah. It's actually theoretical implication.
Yeah, the same opinion. I would like to more as a sum of the parts. Understanding that one.
Oh, really? Okay, yeah.